Hello, friends. My name is Michael Abakumov. I'm Reasonable Faith Chapter Director in Ukraine. And today we will have a dialogue between a physicist and a philosopher on the topic of the argument from the applicability of mathematics. And they will both share the formulations of their argument, and we will also discuss the main issues and objections to this argument. Our format will be as follows. Each speaker will be given the opportunity for 10 or 15 minutes to state their formulation of this argument, and then we will be able to discuss weakness and strength and objections to this argument, and also some questions. Dr. Craig, let's start with you. It is always a pleasure for me to talk with you and listen to you. I'm delighted with your books, and recently Tyson sent me these books, and I currently read your classic work on Kalam. It's so great. And as far as I know, you write in systematic theology, in which you present this argument from applicability of mathematics.
So yes, that's correct.
So how did you even know about this argument, and why is it interesting to you?
Well, it was through Eugene Wigner's very famous article on the unreasonable effectiveness of mathematics. I was aware of this article and its implications, but I had never really bothered to read it or study it and reflect on it. And then a few years ago, I did pick it up and began to study this area, and I was stunned at how persuasive this argument is. I think that Wigner's paper is simply brilliant, and he anticipates and responds to most of the objections that could be raised against his claim that the unreasonable effectiveness of mathematics is virtually a miracle. Now, as a theist, what occurred to me is that Wigner doesn't really take seriously the alternative that the applicability of mathematics is a miracle. As a naturalist, he simply concluded that it's a mystery, that it's a gift that we neither deserve nor understand. But it seemed to me that as a theist, I had a perfectly good and reasonable explanation for this uncanny applicability of mathematics. And so it was through studying and reflecting on Wigner's work that I came to embrace this argument.
Okay, thank you. And I would say, what about you? When did you first begin to research and formulate this argument from your perspective?
Actually, I cannot even tell exactly, because mathematics started to be open to me started from my childhood. When I started actually to study not mathematics but physics, I was amazed. Then the equations, can I write with my pen on a paper, solving some equations, and then I can predict what will happen in nature, and in nature happens exactly like this. I did not know that before writing equation and solving them. So this correlation, strong correlation between mathematical art, I would say, art of mathematics, and the real physical nature, actually made me stunned and mesmerized, sort of, at my childhood. So, and still I'm there. I just developing year after year more and more this miracle. I see it, I think, better. But the miracle is more and more powerful in front of my eyes with the ages, with my learning. So it happened very early, when I was say 14 years old.
Mm-hmm. Okay.
I realized it, and I was shocked by this realization. Yeah, it just happened with me.
Thank you so much. And so let's start with you, Dr. Craig, with your formulation of your argument. And also, in the beginning, could each of you just say a few words for our listeners, who you are and what is your area of specialization, because I suppose some people maybe don't know you.
Certainly. My name is William Lane Craig. I am an American philosopher and theologian. and am currently working on a systematic philosophical theology of the Christian faith.
Okay, and let's start with your formulation of your argument.
All right, if you could bring it up, we have a screenshot so that our audience can follow along.
Yeah.
I have attempted to formulate the argument deductively in terms of these steps. So step one is that mathematical concepts arise from the aesthetic impulse in humans and have no causal efficacy in the physical world. It was Wigner's point that the mathematical concepts arise from the aesthetic impulse in human beings. That is to say, mathematics is an a priori discipline that seeks for qualities such as beauty and fruitfulness and fecundity. They are not motivated by empirical adequacy as the physical sciences are. I added then the point to premise one that these mathematical entities have no causal efficacy in the physical world. If mathematical entities actually exist, then they are Platonic, abstract objects that are beyond space and time and have no causal connection to the physical world. On the other hand, if mathematical objects are just useful fictions, then it also follows that they have no causal impact upon the world. So it seems to me that these provide two good reasons for affirming premise one. Now, premise two is that it would be surprising to find that what arises from the aesthetic impulse in humans and has no causal efficacy in the physical world should be significantly effective in physics. There's no reason that the physical world would conform to these a priori, acausal mathematical entities and concepts. Therefore, it would be surprising to find that mathematical concepts should be significantly effective in physics. Premise three states that the laws of nature can be formulated as mathematical descriptions or concepts, which are often significantly effective in physics. And Wigner gives a number of examples in his original article to show the extraordinary accuracy of the descriptions of the mathematical formulations of the laws of nature. Therefore, it is surprising that the laws of nature can be formulated as mathematical descriptions that are often significantly effective in physics. 5, therefore, the fact that the laws of nature can be formulated as mathematical descriptions that are often significantly effective in physics merits explanation. If there is something that is unexpected, uncanny, then that cries out for explanation and deserves to be investigated. 6, then, theism provides a better explanation of the fact that the laws of nature can be formulated as mathematical descriptions that are often significantly effective in physics than does atheism. My argument here is that whether you are a realist or an anti-realist about these mathematical objects, theism has an advantage over naturalism in explaining their effectiveness in the physical world. If you are a realist and you think that mathematical objects actually exist, then, as I say, they are separated from time in time and space. They have no causal connection with us. And therefore, the fact that the physical world would conform to these physical concepts would be simply a happy coincidence. On the other hand, if you're an anti-realist and you don't believe that mathematical objects really exist, then it is equally extraordinary that these fictional entities should be so effective in describing the real physical world in which we live. On the other hand, if God exists, then on a realist view, God can look to the mathematical realm and create the physical world on that pattern. This was Plato's view in his dialogue, the Timaeus. God looks to the forms and then builds the physical world on the mathematical model supplied by the forms. On the other hand, if you're a theist and an anti-realist, then what you can say is that God has built the physical world on the blueprint of the mathematical concepts in his mind. This was the view of the first century Jewish philosopher Philo of Alexandria, who believed that the world was created by the divine logos, or reason, on the basis of the mathematical blueprint in his mind. So whether you're a realist or an anti-realist, it seems to me that theism has the explanatory advantage over naturalism. 7, therefore, the fact that the laws of nature can be formulated as mathematical descriptions that are often significantly effective in physics provides evidence for theism. So that's the argument. Now, it would be very nice to have a simpler formulation of this than this complicated 7-point argument. So I offer the following 3-point summary. We can epitomize the argument as follows. 1, if God does not exist, then the applicability of mathematics is just a happy coincidence. But 2, the applicability of mathematics is not just a happy coincidence. 3, therefore, God exists.
Okay, thank you so much, Dr. Craig, for this formulation. And Dr. Burov, let's start with you. Now, what is your area of specialization and what is your formulation?
My area of specialization, mathematical physics, and mostly I am working for mathematical modeling of beams in accelerators, and I have been working in Fermi National Laboratory, which is near Chicago. It's one of the national laboratories in the United States. I have been working there since 1997, quarter of century, and I share my time between physics and philosophy, which is also my passion. So that's brief information about me. So if I may share my screen, huh? Okay, may I start?
Yeah.
With my presentation. I prepared some slides with what I call Pythagorean argument for the grand design. Grand design is a term for intelligent design, of purposeful design, for theistic argument. This term was suggested actually by Hawking and Mlodinov. They use it sort of ironically, but I take it seriously. And in the first slide, I show some publications of me together with my son in English language. In Russian, there are much more, but here only in English. And at the left, it is a Springer publication of our essay, which got an award from Foundational Question Institute in 2016, 7 years ago. The contest was called Trick or Truth, the mysterious connection between physics and mathematics. And there we actually refuted multiverse hypothesis as a possible explanation of an anthropic principle, and we refuted it on the ground of mathematical efficiency. And this multiverse hypothesis was, the main proponent of multiverse hypothesis was Max Tegmark for the anthropic argument. And actually it was him who awarded us for refutation of his hypothesis on the theistic ground. And as far as I know, this is the only theistic essay which ever got award from the Foundational Question Institute. So it makes me especially proud because, you know, when you get an award from your opponents, and it's especially valuable to get it from your friends and similar thinkers is also good, but not as honorable, I would say. Okay, so and another publication is on the right with a solar photo. There is our talk with my son Lev, published in the Proceedings of International Society of Neoplatonic Studies of 2019, where we led a panel, Platonism and Contemporary Physics, and we actually gave a talk there and then published there. Okay, so and PythagoreanUniverse.com is our website where you may get this and not only these English publications. So let me start to explain what do I mean by Pythagorean argument of grand design. Let me explain first the character of the physical laws. They are not just mathematical. Actually, there are much more there. The character of the physical laws are such that the laws are fine-tuned to be anthropic. So I would not explain this, assuming that it is a well-known term. This requires sufficient complexity of the laws. Life requires a lot of matching conditions. So even tiny shift of one or another physical constant will make chemistry impossible. You will not have table of elements, maybe just hydrogen atom or not even them. So this is called, the whole business is called fine-tuning and anthropic principle. Life requires a lot of matching conditions. But at the same time, the same laws are discoverable by this anthropy, or sapiences, as I prefer actually to call thinking beings in the same universe. This requires sufficient simplicity and aesthetic attractiveness of the laws. Satisfaction of these contradictory minimax requirements, sufficient complexity for life and sufficient simplicity to be discoverable, makes the universe very special. We call it Pythagorean. So character of the physical laws, a little bit in more details. They are well-established fundamental physical laws have very special characters. They are first expressed by short formulas, not just mathematics, very simple mathematics, very short formulas. They are reasonable and elegant, as we call it. So they obey symmetries and invariances, expected and unexpected. Third, they are universal, valid for enormous ranges of distances, times, and energies, the same simple, elegant formulas. They are very precise, up to 12 digits. They are ordered by discoverability. So the closer to us, the simpler. The simplest physical theory is Newtonian celestial mechanics. And then the further we are going from our scales, the more complicated, the more challenging are mathematics. It's still sort of simple, but more challenging. It's harder to discover. So there is a sort of gradient of difficulty of mathematics. They ordered by discoverability. The deeper laws can be obtained by syntactic transformations. What is called? So this is correspondence principle of Paul Dirac. So I will not explain this, but just in one example. If you take classical Hamiltonian and substitute momentum by gradient operator, you will have quantum Hamiltonian. So just syntactic transformation transfers classical physics, which invalid in the atomic realm, in quantum realm, into correct quantum formula. So this is correspondence principle has a lot of responsibility for quantum mechanics to be discovered. So they are asymptotically exact. Newtonian physics is a mathematical limit of special relativity, general relativity, and quantum mechanics. It's not just patchwork of theories. No, they are in a strict, all the theories, most simple theories are in a strict relation with newer theories and deeper theories. So the asymptotically exactness, we call it. So, and still with all these symmetries and helping properties, the laws of nature are barely discoverable. So they at the age of ability of the founding fathers. And on top of this, they are anthropic. They are compatible with rich life and with thinking living beings. So you see that a lot of consequences there are in the physical laws. They are not just simply mathematical, they are expressed by mathematics, no, much more. So I'd like to present a quotation from Gonzalez and Richards, The Privileged Planet. Like an excellent tutor, the universe has not been so demanding as to ensure failure, but rather has allowed us to succeed while still presenting us with worthy challenges. So this is at this slide you will see you see some formulas for fundamental laws of nature. I will not, of course, explain it, but I just put it here just to see how simple they are, and this simplicity reflects a lot of symmetries. It's not just physicists or mathematicians made this by their hands. No, it's reflection of a lot of symmetries, and that's why they were discoverable, because they were looked like that. So discoverability principle of the Pythagorean universe. Change it like this, yes. The laws combine in themselves a sufficient elegance to make them discoverable with a sufficient complexity to produce the richness of life, including the beings who will be able to discover the laws. We call it discoverability principle, and the universe obeying it. We call Pythagorean. The span of scientific cognition comprises today about 45 orders of magnitude, from the size of the visible universe, about 10 to the 26 meters, to the scale smaller than that of the top quark and Higgs boson, about 10 to the minus 19 meters, whereas LHC accelerator works now. This would not be possible unless the laws were of this very special character. Even a little increase in complexity of laws would create a tremendous jump in difficulty of their discovery. On the other hand, were the laws just a bit simpler, life would be hardly possible, not to mention thinking beings, and this is fine-tuning. Thus, the laws belong to a tight set of the intersection of complexity and simplicity requirements. They belong to this tight minimax, as we call it, of simplicity and complexity. Maybe there is just one set of laws there, our laws. The only coherent explanation for the laws to belong to this tight mathematical minimax of discoverability is that they come from a superior mind, which created our universe capable to not just be inhabited by living thinkers, sapiences, this is anthropic principle, but much more, to be cosmically cognizable by them. There are alternative explanations, and in our papers we refuted them all. Some of them are trivial and simple, and even at the level of stupidity, but some are a little bit more sophisticated. So meta law, so the laws are like that because there is a meta law which requires this. Second, full-blown universe of Max Tegmark, which we refuted in our paper, Genesis of Pythagorean Universe. Progress of humanity, this is explanation of Grattan Guinness, British historian of mathematics. This is, I think, could be refuted easily because whatever is the progress of humanity, the nature should be conformal to elegant mathematics. If nature by itself is not conformal, whatever progress is, you will not be able to discover with your elegant mathematics the true laws. They would be either too complicated or not so beautiful as you expected, not compatible with your ideas of beauty, etc. There is a strange explanation of Karl Popper that mathematics is effective because in the similar way as English language is effective in explaining things. There is explanation based on idea of flexibility of mathematics. Whatever the reality is, you can describe it with one or another mathematical formula. Many philosophers say this. Physicists do not say this because they know that the laws of nature are not just mathematical, but very special mathematics, elegant, short, simple, etc. With a lot of invariances. So that to state this explanation of flexibility of mathematics, it requires lack of mathematical knowledge and lack of knowledge in physics, what physics is, what sort of mathematics it applies. There is an explanation, it is just so, and that's it. No, let's stop there. Many authors suggest this sort of explanation. And there is a skeptic attitude. For instance, Sean Carroll, physicist, whom I'm sure Bill knows well because I saw some debates of you Bill, with Sean Carroll. Sean Carroll sometimes says that we do not know many things. Let's discuss this in 1,000 years or maybe in 1,000,000 years when thinking beings will know hopefully better. So sort of skeptic attitude. I think that all of them could be refuted, and we refuted it in our paper. Right now I will not spend time, but maybe in the question time, in discussion time, we come back to this. So the first, I think the first explanation of the character of the physical laws, the first formulation of Pythagorean principle, belongs to Freeman Dyson. The first answer, why the laws are what they are. Laws of nature are explained, if it can be established, that they must be as they are in order to allow the existence of theoretical physicists to speculate about them. This is nice English humor, but behind the humor there is a very serious idea that the universe is designed to be with such a special laws to be discoverable. So this has a high value for the creator. This is in his book, Infinite in All Directions. And interestingly enough, Stephen Hawking, who is considered as an atheist, and he called himself atheist, he expressed essentially the same idea. Let me quote him. Einstein once asked the question, how much choice did God have in constructing the universe. He would, of course, still have had the freedom to choose the laws that the universe obeyed. This, however, may not really have been all that much of a choice. There may be only one or a small number of complete united theories that are self-consistent and allow the existence of structures as complicated as human beings who can investigate the laws of the universe and ask about the nature of God. So it's essentially the same explanation as Freeman Dyson, and they express it in the same year, 1988. So here I finished my objective part of Pythagorean argument. Now we're coming to subjective part. To be discoverable is not the same as to be actually discovered. The latter requires not only objective possibility, but also the subjective effort, rooted in the faith in the possibility of the fundamental discovery and its highest value, even sacredness of discovery. To illustrate this, I'd like to quote Einstein from his 1948 book, Ideas and Opinions. So it's old Einstein already. Quote, the interpretation of religion, as here advanced, implies a dependence of science on the religious attitude, a relation which, in our predominantly materialistic age, is only too easy overlooked. While it is true that scientific results are entirely independent from religious or moral considerations, those individuals to whom we owe the great creative achievements of science were all of them imbued with a truly religious conviction that this universe of ours is something perfect and susceptible to the rational striving for knowledge. If this conviction had not been a strongly emotional one, and if those searching for knowledge had not been inspired by Spinoza's Amor Dei Intellectualis, they would hardly have been capable of that untiring devotion which alone enables man to attain his greatest achievements. This firm belief, a belief bound up with deep feeling in a superior mind that reveals itself in the world of experience, represents my conception of God. This is what we call it Pythagorean faith. And essentially, actually reading a lot of philosophical publications of the founding fathers of physics, I formulated the core of this faith in 5 points. So first, theism. The world has an author, and he is omnibenevolent and omnipotent God. Second, God is transcendent, while the universe is neither divine nor alive. Third, humans in their core are images and similarities or children of God. That's why we are able to discover the grand design of our Father. Fourth, mathematics belong to the mind of God, and it is accessible to man. And fifth, matter is structured and determined by elegant mathematical forms. This, I think, is the core of what I call Pythagorean faith. It's my own reconstruction, again, let me stress this, from the writings of the founding fathers of physics, from Galileo and Kepler to Einstein, Planck, Einstein, Dirac, Wigner. This faith was a metaphysical and ethical foundation for the fathers of physics. Its truth, as of any faith, can be judged by its fruits, by the value of 45 orders of cosmic cognition and its powerful consequences for the civilization. So, summary, my Pythagorean argument for grand design consists of 2 parts, objective and subjective. Objective. With their very special character, the fundamental laws of the universe can only be purposefully designed to be both anthropic and discoverable by this anthropy. Subjective. The key role in the fundamental discoveries was played by Christian Platonism, what we call the Pythagorean faith. Scientific and technological progress is a long-term fruit of this faith by which its truth should be judged. Both parts of the argument suggest no more than one reasonable answer to the question, why is the universe Pythagorean? It was designed by a superior mind, the all-good creator. So, and here I put some books which relates to the content of my talk, and of course, Eugene Wigner, famous Eugene Wigner paper here. And I think I finished in time. Thank you so much.
Thank you, Alexei. It was very interesting. So, Dr. Craig, what is your initial thoughts about this formulation?
Well, I feel like offering a round of applause. That was a tour de force, Alexei. I'm very impressed. May I ask, have you published this? any place. This is very different than your essay in that essay contest that you mentioned. Have you published the contents of this talk anywhere?
I think it is a sort of mixture of our publications in this FQXI essay and what we suggested to Neoplatonists. This is essentially sort of a little bit more than is written there, but not much, I think. There is one more essay. There is also one more essay which you may find in our site, Pythagorean Universe, which we call Moira and the Lycia of Genesis. Moira and the Lycia of Genesis. This is Platonic reference to Plato, to Socrates' discussion with the lady Diotima, and Diotima told that the beauty is the Moira and the Lycia for Genesis. Moira is a fate, and the Lycia is a goddess of how is it called? Ladies who helped to give birth.
Midwives?
Midwives. This is a midwife goddess. So beauty is midwife and fate for whatever happens in this world. So we use this Platonic idea that Diotima taught young Socrates, and Socrates remembered it in the symposium, this is the dialogue symposium, and he remembered what happened in his youth, this idea. So we use this, and this essay is also there in our site. So I think I did not add something extremely important, but maybe a little bit more, develop a little bit more than there.
Okay. It strikes me, listening to Alexei, that what he has here is a sort of cumulative case based upon the laws of nature that draws together a number of arguments that can be separated and treated individually. For example, in my own work and in the works of a good number of philosophers, the fine-tuning argument is treated separately as an independent argument for a cosmic designer. We ask, why is it, not that the laws of nature are what they are, but why do the constants and quantities have these finely tuned values that permit life? That would be one sort of fine-tuning argument that would be different from Wigner's argument about the applicability of mathematics to the physical world. And then yet a third version would be this argument from discoverability that you mentioned Gonzalez and Jay Richards have. Robin Collins is also very enthusiastic about this version of the argument, namely that we live in a universe which is designed to be discoverable. And I really appreciated the way you said there is this gradient of discoverability from things that are easy to things that are very difficult, but not too difficult for us to get along. So in my own work, I have preferred to tease apart these arguments and treat them separately so as to build a cumulative case for the existence of God. But I think what Alexei does is very effectively combine these arguments into a single, comprehensive, and very powerful case.
Yes, this makes this principle of minimax, because both complexity and simplicity of the laws are required. And these paradoxical requirements of simplicity and complexity brings the idea that maybe our laws are unique. Maybe a little bit more complex, life could be still possible, but the laws would not be discoverable. A little less complex, life would not be possible. This is fine-tuning.
Yes. Now, I would want to say, with respect to that, that doesn't mean that the laws of physics are unique in the sense that God doesn't have a choice, because he could have created a life universe, right? So it would be perfectly available to God to create a universe that was not life-permitting or discoverable, but it wouldn't have us in it.
Right. That's what I mean.
Yes. Yes.
Yeah, exactly. So let's discuss some classical objections to this argument. And the most famous to me, at least, it's Stegmar's objections from mathematical realizability, that I call it. So Stegmar's actually argues that every possible mathematical structure imaginable has a physical expression in some possible universe. So Tegmarks put it like this: all structures that exist mathematically exist also physically. So what you thought about this objection?
You asking me or
you can start.
Okay, so we devoted our paper, as I said, Genesis of Pythagorean Universe, to refutation of this hypothesis of Max Tegmark, and I think we added something new there. The general counter argument to this mathematical universe of Tegmark is that it requires a lot. So too many assumptions. So the multiverse, you need the whole multiverse to explain the anthropic principle, the fine-tuning. But we, as theist, criticize Tegmark. We need only God hypothesis. So I don't think that this refutation is too powerful, because from Tegmark's side, he also requires a simple idea, in a sense that full-blown multiverse is a simple idea. It's expressed in few words. It is also simple in a sense, because Kolmogorov complexity, let me put it like this, Kolmogorov complexity of full-blown multiverse is very small. Very small, because that's all. It's already explained. Huh? So our refutation is this, that although this anthropic logic that only in these universes where the laws are anthropic, the question about why the laws are what they are can be asked. So that is a sort of filter of the universes. But the discoverability doesn't work as this filter. So you should not expect to be a universe to be discoverable if you assume the full-blown multiverse. This is the idea. And by the way, Tegmark himself understood this idea, and he did not know how to solve it. But we did something more. But I would not put too many words on that. So essentially, refutation is this. So in full-blown multiverse, you may expect at best living beings, even thinking beings, but you should not expect the laws to be discoverable. They would be extremely complex, because complex formulas are there are much more complex formulas, long formulas, and non-beautiful formulas than short, beautiful, elegant formulas, which is just a tiny subset of all possible formulas. This is the refutation.
Okay, thank you. Dr. Craig?
As I understand Tegmark, his view is that physical reality is a mathematical object, and therefore there's no question of the applicability of mathematics to the physical realm, because the physical realm is a mathematical object. Now, this is a view that I think is so extreme and so outrageous that almost any alternative would be more rational to believe than that. Since the mathematical realm is timeless, this would imply that time is illusory and that there is no time, which again contradicts experience. It would mean, since mathematical objects are causally inert or effete, that there are no causal connections in the world, which again seems to me to be absurd, that I have no causal impact on anything and nothing has a causal impact on me. It would imply that I, as a person, am actually a mathematical object, which seems metaphysically absurd. A human being is a person, not an abstract object. So virtually any view that a person could propose would be more plausible than Tegmark's extreme mathematical realism. I would also raise a second objection that Donald Page, the cosmologist, has raised, and that is that Tegmark's view of reality is ultimately logically incoherent, because if all mathematical structures are instantiated, that means that self-contradictions would be instantiated, that every mathematical structure would be real, and so ultimately reality would be logically incoherent, and that, I think, is metaphysically impossible.
Okay.
I would have some, as a devil's advocate, temporarily taken this position, I would resist this sort of refutation of Tegmark. I think they are could be counter-refuted. If you want, I may briefly say about them, but if not, we may go further.
Okay, let's do it. Let's do it. It's interesting.
Okay. So first, Tegmark assumes that many things are unknown, and when he is saying that all physical reality is essentially mathematical, he does not pretend to say that he knows or anybody could know at all how this relation could be established. This is just a wild hypothesis. And to say that this wild hypothesis contradict our intuition or our common sense, I think it's rather weak refutation, because many things, for instance, quantum mechanics contradicts our common sense, and even imaginary numbers in its time contradicted the common sense. There are many things which science, mathematics, and physics discovers which at first contradicted the common sense. So this sort of refutation, I would say, rather weak. Also, Tegmark did not say that mathematics is applicable because physical reality is mathematical. This would not because this would not explain the key point. The key point is not that we can use mathematics to explain physical reality, but we can use very simple mathematics. This word simple, elegant, and aesthetic, this is very important. And this cannot be explained by Tegmark. But many people are saying that nothing is very special, that that mathematics is applicable to physics because both are follows from our intuition. So physics builds our mathematical intuition. Also, we have to keep in mind that there are different ways of mathematical applicability to physical world. Remember the Ptolemaic system. It was fully mathematical. It was built on ideas of circles, symmetrical ideas of circles, and it was very effective, very efficient. It explained all the positions of all the planets. And actually, what Copernicus did, he just shifted the center from the Earth to the Sun, but did essentially the same, explained the planets by the circles on circles, what we call Fourier series. Is it efficient? In a sense, yes, because it explains all the positions. But is it what Wigner meant, that unreasonable effectiveness of mathematics and physics? No, it's completely different. Because we have to make a distinction between the physical law and some fitting with some circles on circles, epicycles indifferent, or Fourier series, etc. It's not the same. Because when you will have more information about planets in the Ptolemaic or Copernican, doesn't matter in this respect, system, you will need more circles on circles. And if you will study new planetary system, you will need again develop new circles on circles with epicycles and difference. But Newtonian mechanics, this is a real law of physics. It's just one law, and you need only 6 numbers for the planet, and you know the entire trajectory, whatever planet is, whatever is the sun. This is effectiveness. The simple formulas, beautiful, elegant, explains a lot. Schrödinger equation is very simple, very beautiful. It was written from the idea of mathematical beauty, this correspondence principle, etc. And the whole chemistry is there, the whole chemistry. In just elegant form. This is unreasonable effective, not just applicability of any mathematics, because Ptolemaic system, Copernican system, it's not that, it's something completely different, it's fitting. But Wigner and Einstein and fathers of science told about, not about possibility to fit with the formulas, using some formulas and to fit the motion. No, to explain the motion by beautiful mathematical laws, elegant and short. This is
okay. Dr. Craig, what do you thought about this?
Well, as far as Tegmark is concerned, I think this is a matter of interpretation. As I understand Tegmark, he is a pure Platonist who denies that physical reality exists and says that everything is mathematical. And as I say, that is outrageous. You can't appeal to quantum mechanics and other things that are experimentally verified in order to say that you can adopt views that are metaphysically outrageous for which we have no good evidence at all. I will always have better evidence that I am a person, that time passes that there are causal connections between things than to believe that everything is a mathematical object. And I take it that that is Tegmark's view. Now, I don't agree with it, or I don't disagree at all with Alexei when he talks about the discoverability of the universe and the elegance of the laws of nature and everything. As I say, I'm focused on one aspect of this argument rather than other aspects which he draws into his cumulative case. But I do think that the type of mathematics that Wigner's talking about in the article is, as I explained in my 7 points, the elegant mathematics that are used in the formulation of the laws of nature that have such uncanny accuracy and applicability. And so the type of mathematics that he's talking about is not just arithmetic, but he's talking about the sort of elegant mathematics that is exploited in the laws of nature. And we want to know, why is it that mathematics in that sense is so extraordinarily applicable to physical phenomena? And I think we both agree that the best account of that would be through a divine mind who has created the universe to operate according to these mathematical laws.
Mm-hmm. I fully agree. But I just tried to add something more to your brief logic which you presented in your slides. I fully agree with them, but I think they need to be developed a little bit more. That I would try.
Well, I think that they can be developed more, and you've done an admirable job of doing it. But I don't think that would imply the insufficiency of the argument, as I've narrowly focused. This would mean a fuller case can be made as well. And that's true. You've done that well.
Okay, so if Tegmark's approach is very wild, what about just multiverse hypothesis? It's, in your opinion, Dr. Craig, it's like more probable explanation that's sufficient to explain applicability of mathematics if it's true or not?
And what is the alternative we're discussing now?
Just multiverse without mathematical.
I think that's irrelevant to this problem. Multiverse scenarios might be relevant to the fine-tuning of the laws of nature if you would say that there are other universes that exist as well as ours and that have different constants and quantities in them. And it's just due to a sort of anthropic selection effect that we see the universe around us apparently fine-tuned for our existence. But that doesn't apply to Wigner's argument that I'm focused on here. That's about the fine-tuning. Wigner's argument would apply to the mathematical equations that describe, for example, an inflationary multiverse. And so you can't escape the force of his argument by expanding physical reality to take in more, so long as that physical reality is still governed by the laws of nature, as multiverses are.
Okay. Alexei, do you have some thoughts?
About multiverse, I think we should distinguish between physical theories of the multiverse, which assume some meta law. So our laws are just realization of some meta law. But meta law, again, should be contingent, as our laws are contingent. Because something necessary cannot have a cause as contingent thing, cannot be a cause of necessary thing. So reference to a meta law which generates the whole multiverse cannot explain why the meta law is so specific that it generates such a nice, mathematically beautiful laws of our universe. And it must be specific, because if it's not, it would not explain why the laws are what they are in our universe. So multiverse, for instance, string theory multiverse, it's physical theory, but it does not, in principle, it is not able to answer the question why the laws are mathematically discoverable, because string theory assumes the discoverability. By the very nature of the logic of string theory, it's presumed. So again, it just transfers the question on the level up. So multiverse cannot explain why our laws are so special? Because multiverse would refer you to meta law, which again would require the explanation why the meta law is so special, or to chance. But chance cannot explain the discoverability of our laws to such great order, great accuracy. That's the content of our paper, Genesis of Pythagorean Universe.
Okay, thank you. And speaking about this meta law, many physicists, as you know, search the so-called theory of everything, that some fundamental laws that will explain everything else. So it's just popularization of this idea, yeah? And can theory of everything explain this mathematical applicability? Or on what ground Sean Carroll says that in future we will discover what did this guy mean under this idea?
Yeah, the notion of a theory of everything is to try to have a theory of physics that would reduce all of the fundamental forces of physics to a single force carried by a single particle, so that you would unify gravitation, electromagnetism, strong force, and weak force into this unified theory of everything. Now, very clearly, I think just stating it that way makes it evident that it's irrelevant to Wigner's question of the uncanny applicability of mathematics, because the theory of everything is a mathematical theory of everything. And so it would be applicable to reality, and we wonder why. Why is reality characterized by this particular physical mathematical description? So it just it doesn't connect with the argument as I formulated it.
I would put even more. I would say that if theory of everything, as you, Bill, explained it briefly, would be ever discovered, it could only demonstrate even more power of this unreasonable effectiveness of mathematics in natural science, because it will show that the mathematical edifice is even more beautiful, to self-consistent through this nice and elegant theory of everything. And theory of everything would be either discovered as nice and elegant or never discovered anything like that, because whatever atheist or agnostic physicists are saying, they are looking for beautiful theories only. This is only Ariadne's thread for looking for new theories, mathematical beauties. Otherwise, nobody would like even to try to find ugly theories. Ugly theories are ugly, they're not attractive. And mathematicians and theorists are still humans, and they like beauty. They like beauty. Whatever they're saying about their beliefs, God existence or non-existence, but they're trying to find the beautiful theory. And so that's why the theory of everything, if it would be ever discovered, would be a triumph of Wigner's ideas of discoverability of the very special character of physical laws.
Yeah, it's interesting. It seems to me that this argument can't be refuted.
Well, you see, don't you, why this argument is so powerful? It really is a very, very compelling argument based on a very difficult question. I'm overwhelmed.
Yeah. And so when I read some, for example, Hawking stuff or Alexander Vilenkin stuff, they both said something like this. So Hawking says that the laws of gravity, and because the laws of gravity, we can something from nothing. And Vilenkin says something similar. And as I understand, this idea that exists some eternal physical or something mathematical law, and because they exist, just exist, from this mathematical law we have something. And so this is like just brute fact, I suppose. What is your approach to this idea of Hawking and Vilenkin? So, Dr. Craig.
Are you saying that the alternative here is to just regard the applicability of mathematics to the physical world as a brute fact that has no explanation, that is
as I understand, Hawking says something like this, because he says there exist laws of gravity, and because laws of gravity we have something from nothing.
But I mean, of course, the laws of gravity are mathematical laws. That's the very thing that we're trying to explain. So just appealing to that doesn't provide any explanation at all. It's the refusal to seek an explanation. And it seems to me that it's open to the naturalist to just refuse to seek an explanation, to just say that's the way it is. It's a brute fact. It's inexplicable. But that kind of position, I think, is always inferior to a position that offers an explanation of the phenomenon in question. Theories are preferred in part because of their explanatory power. And so if theism offers a theory that is greater than in explanatory power than someone who simply refuses to seek an explanation and rest content with a brute fact, then I think that the theistic view is superior and ought to be rationally adopted.
Okay.
Yes, I agree with you, Bill. And I would say that a rational attitude to reality is based on our efforts to explain contingent facts by some necessary facts. This is a gradient of rationalism. On this way, physics builds its working hypothesis. Every working hypothesis and big series of physics, all fundamental laws, you may consider, and we physicists consider them as working hypotheses, because we never know the borders of applicability of the fundamental laws of physics. Although we see that the applicability is huge, but still surprise may come any day. So we are open to criticism, and so that we making more and more experiments, checking again, maybe we missed something, etc. So this is a rationalistic attitude. We criticize our theory, we make critical experiments, critical check of consistency, but at the same time, we are picking our favorite hypotheses and rely on them in our, for instance, building machine. For instance, LHC was built just mostly to look for to find the Higgs boson. So the belief on the Higgs boson was a sort of belief in the working hypothesis. It was open to criticism. There are alternative hypotheses, for instance, not one Higgs boson, but 3 or 5, and they were considered. But at the same time, the favorite hypothesis was taken as a main point, and we relied on this. So this combination of reliance and criticism of our favorite hypothesis and building more and more general explanation of contingent facts is a rationalistic attitude. And to say, as for instance, Sean Carroll saying, we don't know many things, let's wait with conclusion. Because we don't know this, we don't know that. So the theistic conclusion from discoverability would be premature. We don't know many things. Well, humanity, most likely forever, whatever would be the age of humanity, finally, will have limited knowledge about themselves and about the universe. But this should not stop rationalists to make the best working hypothesis and explanation. This is skeptic attitude, actually, but skepticism is fruitless. The scientific attitude is based not on skepticism. Among fathers of science, it was not a single skeptic, like Hume, for instance, or ancient skeptics. They were not fathers of science, fathers of mathematical physics, like Galileo or Kepler or Newton. They were not skeptics at all. Also Newton or Paul Dirac, whoever, take the great physicists, there is no skeptics among them. So skeptical position is anti-rationalistic. Skeptical in the sense we don't know, so we cannot formulate a hypothesis because we don't know many things. This is fruitless position, irrationalist position, and goes contrary to scientific attitude. That's my criticism to Sean Carroll and like-minders.
Yeah, well said.
Okay, so, and just briefly last question, I think it's more practical. What is your attitude, Dr. Craig, to this subjective parts of Alexei that say that belief in mathematical applicability in rationality of universe, it's very important to like science and for us personally. What is your thoughts about this? Is this valid argument?
If I understand your question, you're asking what is the importance of the subjective belief in the applicability of mathematics to the progress of science and for everyday life?
Yeah.
I suppose that even though one might not consciously think about this belief, one would nevertheless have to have this belief in order to even survive. I mean, you have to believe that when you put one object and another object together, you've got two objects, or when you subtract things, that these results are correct. And of course, that would be extrapolated to doing modern science. You could not get along in the world without the implicit or tacit assumption that mathematical reasoning is applicable to the physical world. You could not survive.
I would add something more. I think that what Einstein, remember my quotation, Bill, my quotation of Einstein, that the Pythagorean phase, what I call the Pythagorean phase, so cosmic religious feeling or amor dei intellectualis, what Einstein said, relates to belief that fundamental laws of nature are discoverable. This is much more than belief that you may add 1 carat to 1 carat and you'll have 2 carats. It is much more, because it is very much imaginable and even natural to imagine that we humans, tiny temporal beings in this universe with short life, would not be able to discover any fundamental law. We would be able to operate in our backyard, okay, maybe build homes, yes, but fundamental laws of nature, which is sort of axioms of nature, this is the core, the blueprint of divine plan of the universe, the first principles of the universe. For us humans to discover, it is a very bold idea. It's not imbued. It was accepted by tiny group of thinkers. I call them Pythagoreans. Number of them were always very small. For instance, consider famous philosopher Francis Bacon. Francis Bacon did not believe in truth of Copernicus system, because what was his argument? Look, everybody sees that sun goes around the earth. This is a logic, typical logic of common sense of humans. We should believe what we see in our eyes, not to have fantasies about divine plan, how we could know divine plan. To believe that we are able to see divine plan, to see mind of God, that's very bold idea, and I call it Pythagorean phase. And Einstein told about this. That's much more than common belief that we may operate in our backyard with carrots, adding them together. Much more.
Yeah. In response to Mikhail's question, I wanted to emphasize that it's not just scientists who need to believe in the applicability of mathematics, but it would be even cavemen, who don't know anything about modern science, but nevertheless, to get along in the world, they would have to assume that mathematical reasoning was applicable to the real world in which they lived, or they wouldn't be able to survive. So as you say, there's this gradient from easy to extraordinarily difficult, and all of us, no matter where we are on that gradient, are going to have a tacit belief, at least, in the applicability of mathematics to physical phenomena.
Yes, so we should distinguish between empirical operation, which you are quite correctly explained that we cannot survive even without that. We rely on this. From empirical belief of mathematical applicability to this ability to discover fundamental laws of nature, this is completely different things. Even if to take the first great discovery, so Newtonian celestial mechanics, even this is a big step. And it's not surprising. There is a reason why mathematics and mathematical physics was developed after Newton, was developed for centuries only in European soil, nowhere else. Because other cultures, they believed very much in empirical applicability of mathematics, as a caveman did. but they had no idea about the mathematical axioms of nature. They didn't accept that. They didn't accept it for centuries. When in Europe we already was Maxwell, it was Hertz who confirmed the correctness of Maxwell equation. Still, Asia did not accept this, not because they were underdeveloped, because they thought about nature differently, and this was unacceptable to them by the foundations of their thought, which was rich, beautiful in their way, but incompatible with Pythagorean faith.
Okay, thank you so much, both of you. I have so many food for my thinking. It's so powerful argument, and I hope both of you will do well. So thank you, Dr. Kray, thank you, Dr. Burov, for this discussion. It was fascinating, and I hope our audience also will think about this and drew some conclusions. So thank you, and may God bless you both.